Yes, assalamu alaikum, everybody. And as I was I obviously know in a video for a long time, and I want to tell you something though. What are acids, bases, and salt? Now, this is the topic I'm going to tell you. Now, for acids, bases, and salt, you must remember the pH level. The salts and water are always neutral. Now, water is a specific compound because what makes acidic and what makes alkaline and what makes basic things basic is this thing H positive and OH negative. Okay, these ions are present. Okay, for alkaline OH, for acidic H positive. Now this is the whole pH scale, and you have these as the acidic compound or acidic, yes, acidic compounds, neutral compounds, and alkaline compounds. When a substance is in solution and an indicator is added, so that is when the color changes. You have a lot of indicators. This paper changes red to blue in alkaline solution, and vice versa, blue to red. Acidic solutions and universal indicators are actually variable. So they'll show one as a different tint, yellow, green, red. I'll actually might want to show you the picture, okay, some other time maybe. But now I can just tell you that alkali are the only bases which are soluble in water. Actually, I can show you. So I'll just open Google Chrome and I'll show you the universal indicator. It's like really, really good, you guys. So actually just check the universal indicator. As you can see, this is the color differences. Interesting, isn't it? It's actually a mixture of dyes, so that's why. And the acidic compounds have a H positive ions. The H positive ions are overly included, as in HCl, hydrochloric acid, guys. Then this becomes a strong acid. Okay. For the fun fact, let me tell you that weak acid acid has more pH and strong acid has less pH. It's actually opposite in the other thing. Weak alkali have more pH, and I forgot to tell you the alkali are the only bases you're soluble in water. Why do you take bases? Because alkali are the only bases which are soluble in water. Remember that, guys. And basic substances are basically oxides and hydroxide, but alkali, the hydroxide, if you open the periodic table, you will find there are a lot of metals in the periodic table, but the metals of the starting metals, you probably don't count hydrogen, but you count the metals here. Metals in group one, and in group one only, the metals, they're alkali. Okay. Now they're not alkali actually. I forgot to tell you one thing. The oxides and hydroxides of them are alkali. For example, you take lithium oxide or lithium hydroxide. It's an alkali. Okay? I will tell you weak alkali has less pH and strong. We generally take just alkali in the whole base. Base is actually a broad topic. We take alkali in between, inside of bases, a subgroup. But alkali is, you know, really important for major reactions because bases are mostly insoluble in water. That also counts the main thing because they're mostly hydroxide strong, unlike oxides. So yeah, weak alkali has less pH, and strong alkali has more pH. And guys, I forgot to tell you that lithium oxide, lithium hydroxide. We don't use mostly group 1 reactive metals to do experiments, so alkali mostly don't use them. And group 2 actually, group 2 oxides and hydroxides. Um, yeah, another thing that group 1, when you have some dangerous reaction like sodium chloride, ionic compounds, so they basically bond by electrons, you know. Sodium has one electron in its outer shell, um, in its outer shell, so basically it gives an E minus to chlorine, which needs one. So sodium has a positive charge. It has positive charge, as electrons are obviously negative charges. Protons and electrons the same number to balance the atoms, but because of more protons, the nucleus and the electrons, they have equal charge. That's why they become ions. Okay, if there are more electrons, you know, you gain an electron, you have more electrons than protons, you have a negative, negative charge, positive charge, and chlorine, a negative one. Okay, guys, it makes sense. And I think I was telling something which negative. Um, Also that there are some amphoteric and always remember, guys, acid plus base is always salt and water, salt and water, salt and water, salt and water. Just remember that, just memorize it. There's gonna be nothing else which you're gonna find. I was telling you, mineral acids and organic acids. So mostly mineral acids are strong. Mostly organic acids are weak. But there's one mineral acid that is strong. You can actually make this. Sorry, guys. I'm sorry. That's, I want to just write mostly strong and organic acid. Mostly weak. Actually, it's all the time. So you just don't write weak here. Organic acids are weak. You don't write mostly. Sorry. Mostly strong means except for, however, there is an exception, and that exception is carbonic acid. Carbonic acid, why isn't it organic acid? Because carbonic acid's formula is H2, sorry guys if I, COC2 basically. So it has H2CO3, sorry. I cannot actually write it for here. So that's why the carbonic acid doesn't make sense. There's probably a lot of more stuff, guys, and I'm going to explain you in a later class. Now, thank you guys for listening to my whole